Any questions? Any questions? Michelle and Michael and Erez, any questions about anything? Okay, let's jump to the quiz then. Okay, this is just a really weird thing that happened actually, because I wrote this quiz, I think after the last teaching class, which was a week ago. 2 hours ago, a bear went into my trash can. And the weird thing is, it was my pine needle trash can. It's not a bear trash can, I just throw pine needles in. For some reason, the bear was hoping, and all he found was pine needles. But it happens, you know, it's part of Tahoe. So our Tahoe second homeowners more likely than Tahoe locals to leave their trash in containers that bears can get into, okay? The Tahoe Bear League observed the neighborhoods and found that 97 of the 351 second homes that had trash that the bears could get into, and 136 of the 612 local homes had trash that the bears could get into. Use a 5% level significance. Okay, so the first thing, state the null alternative hypotheses. And what I like to do, and I recommend you do it too, is I copied and paste it into the answer area. That way you don't have to keep going back and forth reading. This makes it a little easier to see. So let's start with the null hypothesis. And so the first thing is, hopefully you all know, because we've been doing this a while now, hopefully you all know the symbols that we use for the null and alternate for the null hypothesis. For some reason, I have to unshare and reshare a moment. Ah, there it is. There. Just have to be able to see the chat box. So what symbols are you always start with in any null hypothesis?
HO.
You're all supposed to,
HO.
Yeah, yeah. So it's H naught. And now what we have to decide is what letter do we use to represent the variable? And the key on this one is, what's the survey question? Yeah, the letter's P, because the survey question is, did you leave the trash out for bears to get to? And it's yes or no. So that's going to be P is equal, and it's not just P, there are actually two different populations. So it's, and I better write it this way now, it's going to be P sub 1 is equal to P sub 2. Okay. Okay, and if you want, you could do, I don't know, P sub S is equal to P sub L for second homeowners and locals. Okay. All right. Now for H1. So for H1, what inequality are we going to have, and what's the key word that's going to help you? There's a key word in the paragraph that helps us with the inequality.
The keyword
Yeah,
is
more. Okay, and just I'm going to do in the order of which it's read. So I'm going to let the second homeowners be the first one, and the locals be the second one. So that means P1 is greater than P2. Any questions on part A? Okay, for part B, write down the test statistic and p-value. That we need a calculator for. Okay, I would never expect you to try and do this by hand. That would be really brutal. So we're not going to do that. But what you do need to know is, which of the calculator functions do we need to go to? Give me, what number is it? Yeah, this one's 18 because it's two proportions. So I go to 18. And then my first sample size was 351. The number of successes is 97. And I remind you, success does not necessarily have to be a good thing. Okay, so be careful about just reading that weird. Success just means number of people who said yes. For the second sample, 612. And the number of successes was 136. Okay, we want a greater than. And then we go ahead and if you want a confidence level, it doesn't matter. I didn't ask you, but just fun. 0.95, but you don't need to. And we hit calculate. Any questions on that? Okay, so notice our test statistic is Z, and that is 1.89. Good enough. And our p-value is 0.03. I'll just round to a couple decimal places. Any questions? Any questions at all on using the calculator? Okay, so now I can scroll down and I can write down the test statistic is Z equals 1.89. And the p-value is equal to 0.03. Is that clear? Okay, now it says use a complete sentence to state the conclusion in the context of the study. All right, what are the first two words? Because that helps. Any hypothesis test. Huh?
There is.
Yep, there is. Because I recommend memorizing those two words because it gets you started. Okay, and it's not like some fancy hard words. Okay, there is statistically. And now we have to decide, is it significant or is it insignificant? And notice our p-value is 0.03. We have a 5% level of significance. So is it significant or is it insignificant? Yeah, this one's significant because the p is less than the alpha. So it's statistically significant evidence to support the claim. That, and now we just state down, basically talk about population proportion, okay? And we're looking at Tahoe second owner homeowners versus locals, so that the population proportion of second homeowners that leave their trash out for the bears is more than the population. And now I'll just copy and paste and change a few things. Is more than the population proportion of locals. Tahoe locals that leave their trash out for the bears. Any questions at all? Any questions at all on this idea and this problem? Okay, let's move on to question 2. Okay, by the way, you shouldn't be surprised there were 3 questions. Okay, why were there 3 questions?
Because there were 3 styles to use.
Yep, yep, chapter 10 had 3 different kinds of problems. So I figured I might as well quiz you on each of the 3. Okay, and that's my style, by the way, so expect it. Expect in the final 2. If you do the same style of hypothesis test or the same confidence interval style twice on the final, worry. It means you screwed up somewhere. Okay, so look at it again, because I try not to have you do the same thing twice. But there's definitely 3 different styles of hypothesis tests for 2 variable hypothesis tests. Okay, so question 2. Do male counselors spend less time working with each student than female counselors? 8 male counselors and 8 female counselors were observed. Use a 5% level of significance. The minutes per student are shown below. And here's our male counselors, here's our female counselors. So on this one, we want to first state the null and alternative hypotheses for the corresponding hypothesis test. All right, so the first thing we need to do is consider the survey question. Is this a yes/no survey question, or is this a quantitative survey question? That's supposed to be very obvious. What is it?
Quantitative.
Yeah, I mean, it's obvious because look at the data, they're numbers. Is that clear?
Yes.
Okay, no trick questions on this, but doesn't mean it's easy. Okay, so if it's quantitative, the second thing to ask yourself, now that it's quantitative, are these dependent or are these independent?
These are independent.
And how do you know they're independent?
Because the male counselor and the female counselor are not the same person. So you're not asking the same person the same questions. So they're not in any way related to each other. That makes it independent.
Right, and in particular, there's no pairing between this first male counselor that had 13 and the second that had 16. Okay, yeah, exactly. If you switch the first 13 and 18, that doesn't change the study at all. Okay, now it doesn't necessarily have to be the same person. So let me give you an example where you could actually do this study with pairing. And that would be you hire 8 students to go to a male counselor and go to a female counselor with the same question. And then count how long it took the male and how long it took the female for that student.
But you would specifically put in the question that you
Absolutely.
had done.
Absolutely. But I'm just saying that that there are situations where it could be different people, but they're paired. Do you see that? And this one, there's no pairing. That's the most important thing. Okay, I didn't give you one of those, but you know, had I said we hired 8 students to go to a male counselor and then go to a female counselor each and timed them, then it would be paired. Does that make sense? But here we didn't. The male and we just looked at the male and looked at the female and did the 8 people the male did and 8 different people the female did, and there's no pairing at all. Okay, I just want to emphasize it because that's usually the hardest part of these problems on the final exam, is to decide if it's paired or not. And this one's definitely not paired. Okay, so now what we need to do is state, now that we've got that down, we're going to state the null alternative hypotheses. So the null hypothesis, let me, before I do that, H naught, now I'll go to the equation. So the null, since it's quantitative, we have a mu. So we go to our mu. And then I'm going to go sub m for male equals, we hit mu again. And then sub f for female. Whoops. I think that is a sub, even though it doesn't look like it. Let's see. Yep. Any questions on H naught? And then H1, what's the inequality? What's the keyword that helps us with the inequality? And what inequality do we use?
The keyword is less than, and we use less than.
Yeah, yeah. Or the keyword is less, and we use less than. Okay, so it says less, so we use less than. Again, I try not to give trick questions, even though these are hard. The words are there. The word less is there. You just got to look for it. So that's going to be mu. Sub m is less than mu I'm not going to remember. Did I use F or W? F. Any questions on that? Okay, write down the test statistic and the p-value. So what I'm going to do, I'm going to copy these so I don't have to type them all in. It's a whole lot easier. And then I'm going to go to the calculator. And which calculator do I need to do?
Larry, you don't have a complete copy on that. The first letter is missing, or the first number is missing.
Oh, that'll be a problem, Ashley. Thanks.
Mhm.
There we go. Okay, so now I'm going to go to a calculator, and which one is it? What number?
17. No. 16.
Yeah, this one's 16 because we have data. So it's 2 independent samples with data. And I'm going to paste. And then I can do the same thing with the female. Okay, I purposely formatted the question this way to make it easy for you. I'm not sure if you did that, but doesn't that make it a lot easier if you could just copy and paste? So, you know, I try to be nice to you, but it doesn't always feel that way for y'all. But, you know, because I don't want you to spend all the time typing and looking and stuff. But copy paste is easy. Less than is correct in this one. Confidence level doesn't matter. I think I'll just leave it blank. And what we have now is we have a test statistic T is negative 0.287, or how about negative 0.29? And our p-value equals 0.39. So now we can answer part B. We have T is equal to negative 0.29. And the p-value is equal to 0.39. Any questions so far? All right. The first 2 words are going to be the same. We want to use a complete sentence, state the conclusion. So first 3 words, actually. There is statistically. And now, is it significant or is it insignificant?
Insignificant.
Yeah, because notice that our p-value is 0.39. I gave you level significance, but you don't need to look because that p is so high. Level significance is never that high. Okay, 0.1 is the highest I've ever seen level significance. Okay, so 0.39 will never work. Okay, statistically insignificant. Evidence. To conclude that, and now we're comparing again the time working with students, male and female, that the population mean, okay, amount of time that male counselors work with students is less than the population mean, and I'm just going to copy and paste. Less than the population mean amount of time that female, put an FE there, counselors work with students. Any questions at all on question 2? Any questions? Okay, let's move on to question 3. All right, do college, let's say students, sorry about that. Do college students spend the same amount of time with their friends in person or virtually when there's no virus issue? Okay, 10 college students were observed one day, and the number of minutes with their friends in person and virtually for each of the test students is shown below. Use a 5% level of significance. Okay, so in this example, first thing, is it quantitative or qualitative? So is it quantitative or yes, no is what I should say. Which one?
Quantitative.
Yeah, this one's quantitative because, hey, look at the data. They're all numbers. Okay. The survey question is, how long did you spend? How many minutes did you spend with your friends in person? And that's, I spent 180 minutes or something. Okay. It's a number. It's not yes or no. The second is are this independent or these dependent data sets?
They are dependent.
Yeah, they're dependent because this 155 and this 195 belong to the same person. It's one person answering two questions. Any questions on that? Any questions? That's often the hard part, is to identify the strategy. Where do you start? And in this case, we're going to be looking at a hypothesis test for dependent data. Okay, so, and by the way, you're welcome to do what I did too. I always copy and paste the question into the answer. That way I don't have to go back and forth. So do that too. It saves you time. All right, so we got H naught. And for dependent data sets, we're looking at mu sub D. What does D stand for?
Stands for dependent.
It's a good try, but not quite. Maybe no? Yeah, difference, yeah. As Eric says, stands for difference. It's the mean difference is what we're talking about, not mean dependence, but mean difference between the two. Okay, and that's equals 0. In our class, it'll always be equal 0, by the way. Okay, and then now we go ahead and we look to see what the question's all about. And what is the inequality for H1 on this one? What's the key words?
The key word is spend the same amount, so it's going to be different.
Yeah, not equal to. Yeah, not equal to, because that's the exact opposite of same. Okay, so let's do that. Wait, before I do that, let's go H1. H1, and that's going to be mu sub B is not equal to 0. So mu sub D is not equal. I think it was this one. Not relationships. That one. 0. Any questions on this? Okay, notice this basically turns the survey into a single variable survey question. Turns it into the mean of the differences instead of two different sets. All right, now we write down the test statistic and p-value. Gonna copy this. Doesn't want that first digit again. I'm gonna make it happen. There we go. And let's go find the right test. Which one is it this time? What number?
This one is 19.
Yeah, this one's 19, 2 dependent samples, and we have data. Okay. And that's the first one. Let's go to the second data set and copy that guy in. That's data 2. Any questions so far? Okay, and in our tails, we're going to have a not equal to. And let's calculate. And there's our test statistic, negative 1.55. And the p-value is 0.1516. So let's write that out. So our test statistic is t is equal to negative 1.55. And our p-value is equal to 0.16. Any questions? All right, almost there. Okay, next, use a complete sentence to state the conclusion in the context of the study. So it starts the same way. There is, statistically, and now, I think there's one now. There we go. Significant or insignificant?
Insignificant.
Yeah, the p-value is 0.16. That's bigger than any level of significance, but I think I even told you, use 5%. But even if I didn't tell you, you'd know it was insignificant. Evidence to make a conclusion about whether, and now we're looking at, again, let's look at it, the amount of time people spend with friends in person versus virtually. Okay, so whether the population mean amount of time people spend population mean amount of time that people spend with their friends virtually is different because we have a not equal to from the amount or population mean of time people spend with their friends in person. Any questions at all on this? Any questions? Okay, I just want to make a note because it was in the chat. In terms of pay for tutoring, it's interesting. It's not the money that you're making, actually, it's the learning experience that you're getting. I was a tutor for a bunch of years too, and I'll tell you that really helped me understand, understood the math, understood the, how to work with students, etc. And that's the main thing. The pay is nothing, actually, but the idea is it's good on a resume and it's good for them. Any questions at all on the quiz? Any questions? Hopefully there weren't any surprises. I tried to make them standard, but standard is not always easy. Okay, ready to take a look at the exam? Let's do that. So just note, and I want to do it this way so I can show you. If you go to modules and you go to week 8 midterm exam, because that's when you took the midterm. Okay, if you go to week 8 midterm, then you will see in there somewhere, S2020 exam 2 key. If I click on that, then it pops up to the key. Any questions on how to find this? Any questions? Okay, and what I did is I wrote the key so that the answers are in red and the questions are in black. And I just want to go through these. Write your name. Well, my name is Key. That's one of those that you all got right, which is good. Let's look at the true falses. Okay, so the first one is Courtney will be constructing a 90% confidence interval for the mean weight of pine cones on the ground. There is a 90% chance that the population mean weight of pine cones on the ground will lie within her confidence interval that she will construct. Okay, and this is what confidence levels are all about. So just note, and I want to mention this because I'm not sure if everyone gets it. Before you do the study, then you can say there's a 90% chance. After you do the study, then you can't talk about a 90% chance because you did the study already. It already happened. It's kind of like, you know, what is the probability that it rained yesterday? Anyone know? Okay, I guess it depends on whose house. It's 100% me, for me. Didn't rain where you were, it rained where I was. Okay, at my house. But the point is, it's either a 0% or 100%. So you can't just say after the study, but before you do the study, there's a 90% chance that your confidence interval will end up containing the true population mean in this case. Okay, for project 2, the idea on project 2 is a little different. It's a really good question. And for project 2, what's going to happen is no one's telling you what to do for your confidence level. So what you're going to do is you're going to collect your data first. Then you're going to play with a couple confidence levels. It's very easy in the spreadsheet to change a 90% to a 95% to a 99%. And then you're going to look at the pros and cons of each of the 3 levels. Does that make sense? And talk about it. And then say, you know, based on the pros and cons, which is the best confidence level to give you that confidence interval. Does that make some sense? Okay. Yeah, it's gonna, you know, it's hard to talk about until you do it. That's the problem. But confidence levels you usually decide afterwards. Okay, whereas significant level, you're not allowed to decide afterwards. You have to decide before. So there's a big difference between the 2. Okay, and don't say that because of this significance, I use this confidence. Nothing to do with each other. Okay. So again, you're going to look at 90, you're going to look at 95, you're going to look at 99. You're going to look at the width of the confidence interval versus the fact that if you have a lower level of confidence, you might be wrong. And those are the kind of the pros and cons, and you see which you're okay with. And then if you're not okay with any of them, that means your standard error is bad. And what's the only way to improve on the standard error? Okay, what makes a confidence interval okay? Well, if I did a confidence interval for, let's say, how tall college students are, and I said they're somewhere between 6 inches and 100 feet, that's not okay. Why is that not okay? Yeah, because you knew that. Not just everyone, but that doesn't give you any helpful information. On the other hand, if I said that you know, average height of college students was between 5'5" and 5'6", well, that might give me something. Do you see that? So you have to decide whether your confidence interval is actually helpful to your client. Remember, you have a client. Okay, it could be a made-up client, but you have to have a fictitious client. So hopefully that helps out. These are good questions. These are really good questions. Okay. On the other hand, if you have a 90% confidence interval and it's a disaster, you know, someone's going to die if you give this confidence interval and you publish it and then everyone goes by it and then it turns out wrong, then 90% is not okay. You probably want 99 or 99.9. Does that make sense? So those are the pros and cons. You have to think about what are the problems by being wrong versus what's the problem of having a really wide confidence interval. Okay, and it's a give and take. You can't have both. Okay, unless you decrease the standard error, and you do that by increasing the Okay. All right, let's look at number 3. If the width of the confidence interval is doubled, then the margin of error will also be doubled. Okay, and this is yes, because the margin of error is half the width. You double the width, you can double the margin of error, and vice versa. Any questions on number 3? Okay, number 4 is if x follows a standard normal distribution, then the probability that x is between negative a and a is equal to 1 minus twice the probability that x is less than a. This is also true. Okay, this helps if you draw the picture, but that's how you actually compute it, is that you look at the negative a to a, and you say outside of that is 1 minus that probability, and then you divide by 2 to get the left-hand side. Okay, we've talked about it before. Okay, number 5, the sampling distribution for sample size 60 will have half the standard deviation compared to the standard deviation for sampling distribution for the same population with sample size of 30. And that one's false because it's not half, but it's a divide by root 2. Because you got to divide by the square root of that quotient, not just the quotient. Any questions on number 5? Okay, number 6. ARED selects 5% level of significance for a hypothesis test to see if more than 30% of all people who are invited to a wedding will not come for fear of COVID-19. And if 30% of all people invited to a wedding will not come for fear of COVID-19, there will be a 5% chance that he'll end up concluding that more than 30% of all people invited to a wedding will not come for fear of COVID-19. That's exactly the definition of the level of significance, type 1 error. That's why it's true. Any questions on this? By the way, I should give you a warning. Don't think that you could, look at like last year's final and get it from a friend, which is fine if you can do that. And that I'm just gonna re-give you last year's final. How do you know that 100% true after looking at this midterm? Why is it obvious? New names, yeah, that's one thing, but even more so, look at number 6. Do you really think I gave this on last year's final? Yeah, I mean, I would have to be some kind of, I don't know, God or something if I knew that it was going to happen, and I didn't. So just let you know, I try to make the questions different and meaningful each time. And the names are just fun. I just throw in the names. Okay, let's look at number 7. Okay, Kamal conducts a hypothesis test to see if the population mean number of hours that nurses work per week is greater than 40. If Kamal found the p-value to be 0.02, then there's a 2% chance that nurses don't work more than 40. Okay, that's not what the p-value is. Okay, the p-value would be that if nurses do work on average 40, and if another study was done, then there'd be a 2% chance that the other study would come up with results as extreme as what this study was. Very different than this. Any questions on number 7 on why it's false? Okay. Now let's get into the non-true false questions. Okay, last year it was determined that college students got an average of 6.5 hours of sleep per night. Austin has hypothesized that this average has declined since the stay-at-home orders. He's considering delaying a program that will require students to go through a 5-hour training to educate them on the value of getting more than 6.5 hours of sleep for health reasons. 48 college students that he surveyed this month averaged 6.9 hours of sleep per night. Their standard deviation was 1.2. Okay, state the null alternative And the key here is how many hours of sleep do you get? That's a number, right? I get 6 hours, for example. That's a number. And also, so that tells you that mu is 6.5 because we're comparing it to the known 6.5. We want to see, okay, or Austin wants to see if it's declined. Well, declined, another word for declined is less than. So H1 is mu is less than 6.5. Any questions on the first part? Okay, let's look at the second part. Find the test statistic and p-value. So that's a matter of computer work. And I got a gigantic p-value, by the way. Okay. And the test statistic was 2.3 or so. And then write the conclusion. Well, the p-value is gigantic, so they're statistically insignificant. Okay. That, by the way, if you didn't have those two letters in, okay, I know it's just two letters, but that's a disaster because then you're actually coming up with the exact wrong thing. Okay, that's in terms of real world, that's as bad as it could ever be, is to come up with the exact wrong conclusion. So there's insignificant evidence to conclude that, and I require the words population mean. If you don't know the words population mean, I take off points. Okay, and just let you know that's going to continue on if we're talking about population mean. Hours of sleep that college students have gotten since stay-at-home owner is less than 6.5. Any questions? Okay. Was the sample size or normality necessary? N was 48, that was given. 48 is bigger than 30. Central limit theorem guarantees normality, so no, it was not necessary. So please ask if there's any questions about any of these. Okay, use part 3 to decide whether type 1 or type 2 are of concern. So first thing, we have insignificant evidence. That means we failed to reject the null hypothesis. The type 2 error is the one that talks about failing to reject the null hypothesis. Okay, then I specifically discuss the repercussions. Okay, so, and I've gone over this. So again, always listen because when I go over stuff in lecture and stuff, because I'm going to test on it. The word repercussion means the damage done and who gets hurt. Okay, so in this case, instead of just defining what a type 2 error is, well, if a type 2 error happened, that means that Austin was not able to show that it has declined when it did decline. Okay. Well, if he's not able to show that that the amount of sleep declined, then he's not going to delay the program. He's going to have this program. Okay, but it did decline. Okay, does that make sense? So that means he's not going to be able to have the training session. And if he's not going to have the training session, that means that people are not going to get enough sleep when the training session could have helped them learn how to sleep better. And you're going to have people getting sick and grumpy and, all kinds of issues for not having enough sleep. So the damage, the repercussions are a lot of sick, grumpy people. Any questions on that? Okay, let's go to number 9. Okay, 28% of all STAT students use tutoring services. Ivan wants to see if this has changed now that tutoring is online. Of the 250 students who are part of Ivan's study, 76 use online tutoring. Okay, so note for the null alternative hypothesis, you either use the tutoring or you didn't. Is the survey question? It's yes, no. So that means we get P. And we want to test to see if it's 28%. So P equals 0.28. And then for the alternative, we want to see if it's changed. Change means not equal to. Any questions on the hypotheses? Okay. Then I found my Z and my P using the calculator. Got these numbers. Okay, and I've noticed that that doesn't seem to be a problem using the calculator. It makes me feel good because it means the calculator's working. Okay, but at least you're getting those right if you go to the right menu item. Okay, so then state the results. So there is statistically, we have a high p-value. So it's insignificant evidence to conclude that the percent of, and I want to highlight this, all students, all statistics students at colleges have used tutoring, that have used tutoring now, that the tutoring is online differs from 2.8% or 28%. So if you don't specifically refer to the population proportion by either stating population proportion or by using the word all in this case, then I took off points. Okay, level of significance represents probability. So if 28% of all students at community colleges have used tutoring services since it has gone online, that's a restatement of H naught. And that's how you always start, whether you're doing level of significance or p-value. And another study of 250 students is conducted. Then there'd be a 5% chance, based on the new study, that we would falsely conclude that the percent of all statistics students at community colleges that have used tutoring now that the tutoring is all online differs from 28%. Any questions on part 4? Okay, part 5, now it's p-value, but we start out exactly the same. I'll let you read through this later if you want. But then you say there'd be a 40% chance, because the p-value is about 0.4, that the number of these 250 students who use tutoring online is either at least 76 or at most 64. So 76, by the way, that was the results of the sample. How did I get to 64? How did I get to 64? That took a little work. Anyone know? I know a couple of you got it. Okay. What you can do is you can say, well, 28% was the null hypothesis. If you take 28% of 250, then you get 70. 76 is 6 more than 70. 64 is 6 less than 70. It's always above and below when you're doing a two-tailed test. Any questions on the 64? Okay, we're going to construct an 84% confidence interval for the percent of Americans who have gained at least 10 pounds in the last 4 months. Okay, if you want the margin of error to be more than plus or minus 2%, how many should he survey? So in this case, this is a how many, so that's a sample size question. Okay. Yeah, use percents, and that's fine too. The reason in my key I decided not to use percents was I thought it was just a little easier to read because the 76 is right there. So then you can see where this 76 came from. At least half of it, it's immediate where it came from. But I accept that. If you look at your comments, if you got the percents right, I didn't take off points. For me, it's about teaching, so it's just easier to explain the 76. Okay, so in this case, we want to find the sample size. So first I need to get the Z. And what you do for that is you take 1 minus 0.84 divided by 2, you get 0.08. Then you find the basically inverse of the normal distribution, find that Z that corresponds using the calculator. And we end up getting this big ugly number. I obviously copied and pasted it. E is 0.02. I pop it into the formula for sample size, and I got 1233.89. You always round up. It's a pretty number, 1, 2, 3, 4. Isn't that pretty? I didn't plan that either. Any questions on number 10? Okay, let's look at number 11. We're getting close. Okay, Lydia is interested in the mean amount of money that Californians spend on food each week. And here's what we've got. Come up with the appropriate 95% confidence interval. I use a calculator. I think everyone did fine on that part. Interpret it. Remember, you always start with 95% confidence. That needed to start that way. And then you have to have the words population mean. Amount of money that Californians spend on food each week is between these numbers. And I didn't take off points, but you should either go 2 decimal places or no decimal places. This is money. I think one person did 1 decimal place. No one does that for money. So either $56.51 to $76.83, or between $57 and $77. Okay, so that would be a reasonable answer. Okay, 95% represents a probability. Interpret it. So if many groups of 15 Californians are surveyed, then each group's data would generate a different confidence interval for the population mean amount of money spent each week on food. 95% of these confidence intervals will contain the true population mean amount of money spent on food. Any questions on 11? Almost there. I'm going fast because this is online, so you can go and look at it again. But you can also ask questions if you have them. Okay, so the next question is a normal distribution question. Okay, the mean was 5,000, standard deviation 2,700. Okay, by the way, I totally made up these numbers. I wanted nice numbers. So don't quote me on any of this stuff. And that's typically true of most tests, is that I usually make up the numbers. I try and make them somewhat reasonable. Okay, we want to find the probability that a randomly selected American will take between 4,000 and 6,000 steps. Okay, so now it's just a single American. So now it's an X. So it's X tilde N, 5,000, 2,700. We can go to the calculator, pop that in, and you get 0.2889. Okay. This refers to just an individual. So central limit theorem doesn't apply. So that means the assumption of normality was necessary. Okay, if you track 39 randomly selected Americans, find the probability, and I want to highlight this, that the mean is less than 4,500. When it's a mean, then we're talking X bar. And the formula is that the mean stays the same, but the standard deviation gets divided by the square root of the sample size. And I get this number, pop in the calculator, I get 0.1237. Okay, notice that 39 is bigger than 30. So that means the central limit theorem does apply and the normality assumption was not necessary. Any questions on part 2? Okay, part 3, find the 80th percentile for the total number of steps for 22 Americans. What's the key word here to decide what variable we're looking at? Because this was the hardest part about part 3. Yeah, total. When you see the word total, that means you're adding them all up. And that's why it's not a mu, it's not an x, it's a sigma sub x. Okay? And the formula is you take the mean and multiply by the sample size for the new mean, and you take the standard deviation and multiply by the square root of the sample size for the new standard deviation. Okay, we want the 80th percentile. So we can use a calculator, and I got 120,658 for the total number of steps. Notice that the sample size was 22. 22 is less than 31. So the central limit theorem does not apply, does not give us normality. So that means the assumption was necessary. Any questions on 12? We're almost there. Okay, 13. Okay, you're interested in the percentage of Californians who plan on voting in the November election. 347 of the 425 registered Californian voters who you surveyed plan on voting. We want a confidence interval, so I use a calculator, got these numbers, and then interpret it. So with 95% confidence, that's always how you interpret the confidence interval. Between 78% and 85% of all, let me focus on all Californians plan on voting in the November election. Any questions on that? Okay, sample size. Okay, the key here is the survey question is, are you planning on voting in the election? And the answer is yes or no. So don't give me a 30. So the idea there is it's NP and NQ. We worked those out. NP was 347, that was given, because that's the number of yeses. NQ is the number of no's. That's going to be 425 minus 347, which is 78. They're both bigger than 5. So yes, the sample size is large enough. Any questions at all on the exam? So today was a lot of going over test question day. But again, the stuff's on the final, so you need to still know it. Okay. Now let's get to new material. And what I thought I'd do is kind of show you where some of this stuff is used, because that's important. The first thing is we're going to be doing in chapter 11, we're analyzing qualitative data, and it's a little bit higher level. This is as high level as it gets when it comes to statistics. This one and chapter 13, it turns out. And you're never going to see it in just like a news article. Where are you going to see high level stuff? That you probably will see. Where are you going to see kind of higher level statistics? Any ideas? Don't see y'all jumping in. Yeah, so more sophisticated, not for the general public, too hard to understand. Getting into the kind of gory details. Math labs, you probably won't see that because I don't think any of you are math majors. Okay, but you will see it. There's a reason why you have to take this class. Okay, I guess I need to tell y'all. You're going to see it in journal articles, peer-reviewed journal articles that happen in your major. So it's going to be your upper division work. So if you're a psychology major, you're going to see it when you have to read journal articles. Okay, if you're a nursing major, you're going to see it when you read the details of the FDA analyses of a study that they've done on medicine, for example. Okay, well, if you're a kinesiology major, you're going to see it in your upper division classes to find out, which exercise works the best. You're not going to see it on CNN, but you're going to see it in the advanced stuff. And just to let you know, I don't even know if y'all know this, but I'm going to start with this one because this one was kind of in the news recently, sadly, actually. But just let you know that our library subscribes to a very large collection of high-level journal articles that, as a student, you have access to. Otherwise, it's very expensive, by the way. And that's where I grabbed these. I grabbed these from our library. Our service is called EBSCOhost. And you can get articles that are high level. And I grabbed this one because this is kind of sadly and unfortunately big in the news lately. And let me read the article. And that is, why can't I stand out in front of my house? Street identified Black youth and adult young negative encounters with police. Okay. My guess is you've all been reading the news at least a little bit. I think you have to read it for 2 seconds to know what's going on. And unfortunately, we had a horrible incident not too many days ago. And one of the problems is that there's a lot of prejudice, and it sucks. I wish we didn't have prejudice, and we need to do something about it, but there is. So this is an article from Sociological Forum, okay, from the Eastern Sociological Society. And in particular, they did, let me find it right here. And I'm not going to get into the details. The details are too hard. Let me make it big again. So chi-square and ANOVA analyses suggest an interracial relationship that exists between race, gender, and age on experiences with police. Okay, so I figured I'd bring in an article. I always, if I can, I like to bring in an article that is relevant. And like I said, this is the relevant article that's going on now. And if you want to, study whether experience with police has anything to do with race. So if you want, for example, the proportion of people who end up getting thrown on the ground by police, does it make a difference what race they're in? Okay, whether they're Black or Hispanic or Caucasian or Asian, whatever. Okay, so the survey question here for the person who got thrown down, okay, is you're going to kind of have two survey questions. One is, what is your race? And the other is, were you thrown down? Does that make sense? Okay, and that's kind of what we're looking at. And we want to say, are these proportions the same or are they different dependent on race? Okay, and you could also do dependent on gender. Okay, and especially, by the way, in modern times, we can look at multiple genders. We could look at male, female, and transgender, for example. And then all of a sudden, it's not a yes/no question. Okay. Age, it turns out, is not what we're doing this week. But I figured I'd throw this article up anyway. It says chi-squared and ANOVA. Do you think you're ever going to do ANOVA in this class? Yes, that's chapter 13. So I figured I'd throw it in just to let you know that this is going to happen too, is that we're going to be talking on ANOVA, and that's about age, because age actually is quantitative. And that we'll talk about another time, but not today. But we can talk about race and gender and seeing, does it make a difference? Does that make sense to y'all? Okay, and again, I'm not going to go into all the details, but you'll notice it's a very long article, so I'm not going to read it all. We don't have that much time left. It goes on and on and on. But if you go and, let me find it. I think it's a little lower. There it is. Okay, down here, when they did the analysis, they had a chi-squared of 51.64, and P is, so this is just wrong. What's wrong with this? P is less than 0.000. It's always good to see if you guys can analyze a project and know that there was a mistake or a journal article. Yeah, why can't it be? I'll make it a little bigger for y'all. Any ideas? Yeah, you can't have negatives. P stands for probability, right? P in p-value is probability value, and probabilities can't be negative. So they screwed up. I don't know exactly. My guess is it's less than 0.0001. Okay, is my guess. Because it turns out, again, you're not familiar with this, but I am. This is a gigantic chi-squared. So that the p is going to be really, really small. Okay, which does say that not all the genders are the same. Okay, when it comes to getting stopped by police. Okay, any questions on kind of this idea of why you need to do a hypothesis test that's different when we're talking about qualitative data, like gender, whether there's 3 types, or like race? And I will let you know, how long do you think it took me to find an article that had chi-squared that involved racial inequality? Because I went and looked before class. You know, obviously I didn't do this a year. Not even 5 minutes. It's about 2 or 3 minutes. Okay, they're everywhere. This stuff is important. Okay, chi-squared happens a lot. You've probably never seen it because it only happens in journal articles. That's just a note. And I've used it also for my consulting work. So I have done chi-squared analysis on consulting work. I'm not going to get into the details, but I do consulting. And I don't know if you know, maybe I should tell you now. Do you know what I charge? Maybe I've told you before, I don't remember. It's important if you ever need me as a consultant after you take this class. I don't know what my deal is. Okay, no one wants to guess. So here's my deal. If you're still a student, okay, 150 an hour, cheaper for students. Okay, definitely cheap for students. So if you're still a student, whether you're a graduate student or an undergrad, I don't charge anything. Okay, if you ask me for help, if you ask me to take your test for you, I will say no. But if you're, if you're doing a research project and you need some help, I'm happy to help you anytime, for however many years it might be. Okay, and if you ever get a PhD, send me your dissertation. I'm actually reading one right now. It's going to take weeks. It's on, it's a high level physics dissertation. And it's 150 pages of high level stuff. So if you ever, as a student, need me to help, I'll help you. Then if you have a business and you're not a student anymore, here's my charge. Then you don't pay me, you pay the college and you have to donate to a scholarship. Whatever that it would cost otherwise. That's my charge. Okay, and there's a scholarship that I give for math. So that's my charge. That could be 10 years from now, whatever. I actually had a guy donate 5,000 to a scholarship. I did a lot of work for him. That was really nice. Okay, so that's my charge. If you ever need my help, and chi-squared has happened a few times. I usually it's usually about 1,500 a year, and some I give myself, some I work, and then someone donates in my name or whatever. So that's what I do it's a math scholarship. Okay. Anyhow, figured I should mention that just in case in the future you think about me. Okay. Let's do some more fictitious stuff because it's too hard to read journal articles. Okay, that's something I'm going to let your upper division professor help you with. So I don't want to get into the details, but we could do the basics. So let me do an example. Suppose you want to find out if so let me come up with a good one. If the proportion of students is the same based on major when it comes to whether they get a bachelor's degree. Okay, so what we're going to do is we're going to survey a whole lot of students. Okay, and we're going to find out what their major is. And let's suppose that we classify the majors the following. Let's say we have STEM. So STEM majors, humanities, and let's just go other. Easy enough. Okay, and those are the 3 different majors. Okay, so now what we need to do is we're going to survey a bunch of people, and we're going to see whether those proportions are the same or not. Any questions on that? Okay, so suppose, whenever I say suppose, that means I'm totally making this up, but it could be done. So we surveyed, or we, yeah, surveyed is fine. $200 former. The proportion who get a BA. They start with the major and see if they actually make it. Does that make sense? Former STEM students. And 128 of them got a BA. Okay, any questions so far? Okay, we surveyed 150 humanities students. I'll just write hum. And 70 of them got a BA. And we surveyed 86 others. And 44 got a BA. What can be concluded at the 5% level of significance? Any questions on the question? Any questions on the question? Okay, so this is different than anything we've done before. Okay, we haven't learned how to run this hypothesis test yet. Okay, because the thing is now we have 3 different groups. I want to see if the proportions are the same. Any questions on that? Any questions? All right, so what we can do now is we can state our hypotheses. I want to give you a big warning. I think I'm going to give you this warning in red because it's a big problem that I notice a lot with teaching. So here's a warning. For chapter 9 and 10, and I'll even write and 12, which you don't know about yet. All null and alternative hypotheses have symbols only and no words. Okay, again, this is one of those warnings that you won't even think about because, of course, because that's what you've been doing, right? But why am I giving you this warning in deep red? Any thoughts? Any guesses? Okay, I don't see it. Here's the reason. Because in chapter 11, the hypotheses are going to be in words and no symbols. And what happens is that everybody forgets about symbols, and then they can't write a null alternative hypothesis for chapter 10, 9 and 10 anymore. So don't forget how that 9 and 10, you're going to use symbols with like a P or a mu for the hypotheses. Got it? Okay, again, it's a big issue that I've noticed, you know, on the final exam. So here's a warning. All right, so now let me state the hypotheses. So we start out the same, H naught. And now what we're going to do is we're going to look at this and we're going to say, well, if you look at the percents, if they're all the same, what's the math word for saying everything's the same? When you have multiple things, you want to say they're all the same probability of success for no matter what. Do you remember the math word? We had a whole chapter on it. Long time ago. That makes it hard. I don't see y'all jumping in. The math word is uniform. Uniform distribution means everybody's the same. Do you remember that? Okay, so let me write down the distribution of success, BA receiving students is the same for each major. I want to note something else. I'm going to boldface this distribution. Actually, I just said is the same, is uniform. Based on major. Okay, so each of the majors is the same. The word we use is uniform, has a uniform distribution. And note this word distribution. When you're doing this kind of hypothesis test, you have to have that word in H naught. H1, I'll tell you, if you're typing it out, it's really easy. Any guess on the difference between H naught and H1? Very small difference, very important small difference. I'll paste it in, and then I don't have to change much. What do I have to change? Any ideas? Just put a not here. So the distribution of BA receiving students is not uniform based on major. Any questions on that? Okay, so now what we're going to do is we're going to say, well, what was the total sample size? Yeah, exactly. For this chapter, H9, H1 will be in words. That's never a problem. The problem is people in chapter 9 and 10, when they write in the final on H9, H1 for the final, they don't use words. They don't use symbols, they use words. So that's why I'm not spending a lot of time saying you need to use words on chapter 11, because everyone does. That's never a problem. But chapter 11 uses words, because there it is. There's no nice way of writing this in symbols, by the way. Okay, so now what we're going to do is we're going to use what's called a goodness of fit test. Let me make that big and highlighted, because that's the name of the test we're doing. This is a goodness of fit test. Okay, and sometimes I call it, in fact, let me even write this down, is a chi-squared. goodness of a test. Usually put a dash between chi-square. Okay, so that's the name of the test. And what you do is the first thing we do is we need to make a table. I think I can insert a table. Yep. So what we're going to have now for the table is like so. So the three types that we have, again, we had the STEM. We had the, and in fact, I think I'm going to insert, I wonder if it'll let me do it. Yeah, insert a column to the left. So we had the STEM, we had the humanities, and with the other. Any questions so far? Then we're going to have the observed, and we're going to have the expected. Any questions so far? Okay, the observed, notice that of the STEM students, 128 of them got a BA. So I'm going to put 128 right there. For the humanities, it was 75 got a BA. What's this? And for the others, it was 44 got a BA. Any questions on how I got those numbers in that table so far? They're given. Those are the observed successes. Okay, now we're going to go for expected. Notice, by the way, let's look at this. Our sample size, our total sample size, it's 200 plus 128, that's 328, plus 150, that's 478. So I'm just going to write that somewhere. So that's what, 478. Any questions on that so far? And the total successes. That was equal to 128.75 is 203, and 44 is 247. Any questions on that? Okay, our null hypothesis is that it's uniform, which means the percent should all be the same. So notice that if you take 247 and divide by 478, that is equal to, and let's work this out, 0.5167 is good enough. There. Any questions on that? A little bit of arithmetic. Okay, so we would expect that the proportion of successes for everyone would be 0.5167. Okay, notice for the STEM students, we had 200 in the survey. So if we take 200 and multiply by 0.5167 and get around to the nearest whole number, which is standard, then what do you get? So if you want, we can throw it in there, pop it in our famous calculator, and you get 103. Then we can do the same thing with the humanities students. Uh-oh, what just happened? And there were 100 and let's see, there were 150 humanities students. So we're going to do the same thing with humanities, 150 times 0.5167. Let's figure what that is. You get about 78, sorry. Round to the nearest whole number. And then for the others, there were in the sample 86. So we're going to take 86 times 0.5167. And what you get is about 44. Any questions on those calculations? Okay, those are the expected. And so we have 103. We have 78 and 44. Just a note, are the expected the same as the observed? Did we observe what we expected exactly? No. Does that mean that we can say that the distribution is not uniform? What do you think? Okay, the answer is we can't do that. This is what hypothesis testing is all about. We only have a sample. We don't have the whole population. When you have a sample, you're almost never going to get exactly what you expect. The bigger question is it so far from what you expect that you reject the null hypothesis or not? Any questions at all on this idea? Okay, so the next thing we're going to do, and you're used to this, is we're going to go to our calculator. And here's the set of calculators. By the way, we're towards the end of the class, which means it's going to be pretty low. Okay, and this is number 20, goodness of fit. So I click on that. And here's what it says. Type in the values from the observed and expected set separated by commas. So what I'm going to do is 128, comma 75, comma 44. Those are the observed. The expected were 103. Yeah, 103, 78, and 44. Any questions at all on that? I think there's a mistake in here. Let me double check that. I think the 103 might be wrong. No, that's right. Okay, so then, very simple. You type those in, you calculate. So what do you think? I know we haven't done chi-squared yet, but I bet you know what you can do just based on the results here, because we've done enough hypothesis testing. So what do you think? Based on the results that you're seeing in the calculator. I think I'll even highlight something to help you out. Any ideas? It's something you should all know by now. If you see P equals 0.0454, what does that tell you? You don't remember? Okay, so the p-value is 0.0454. Standard level of significance, and this would be standard. This is just a, no one's going to die because of this study, that's for sure. Standard level of significance is 0.05. 0.04 is less than 0.05. So you reject the null hypothesis. Okay, I want to mention that the test statistic, 6.18, and the p-value is 0.045, because that's often what you're asked to find is the test statistic and the p-value. You've seen that on the last exam, for example. So the test statistic was, this one is a tough one. So first thing, there's no way I can do it without making an equation. Okay, this is not an X, by the way. Okay, it's a Greek letter, and it's the Greek letter chi. And we call it chi squared. I am not going to get into the details of why we call it chi squared, but there, as you might guess, there's a square going on in the calculation. I'll tell you that. So in fact, the test statistic is always positive because it's got a square in it. So the chi squared was equal to 6.18. And the p-value was equal to 0.045. Okay, and by the way, I'm a little worried because I'm looking at the numbers, they look a little off. So if I made an error, in the calculator work, I apologize for that. But that's not important for learning at this point. What's important is you understand what to do now. So that means, hopefully, what are the first few words of what I'm about to type to state the conclusion. And you all know the first few words. Not if, but there is. There is statistically, and is it significant or insignificant? Yeah, this is significant because the p-value is less than the standard level of significance. Statistically significant evidence to conclude that, and again, now we have to go over here. And the nice thing is, I've already got it written down. That's H1. So I can just copy and paste it. So I conclude that. It just happened on. Uh-oh. There we go. That the distribution of BA receiving students is not uniform based on major. Any questions? Any questions on the conclusion? Any questions at all on that? Okay, so there's an example. By the way, had the p-value instead of been, say, 0.04, let's say it had been 0.14, then the only difference is that you'd have insignificant evidence to show. That's the only difference. Any questions on this goodness of fit test? Okay, let me give you another example. I'm going to do the third type because we only have so much time. So let me give you another example. Okay, so suppose last year, 35% of LTCC students who took stats were Caucasian. 38% were Hispanic. And the rest were of other races. Okay, I'm totally making this up. Don't quote me on any of this, but it feels about right. We have mostly whites and Hispanics at this college, and then a mix of other races. Okay. You want to find out if the distribution has changed Okay, and actually, let's go instead of LTCC, let's go CCC. Make it a big population. Distribution has changed this quarter. Actually, I should say this term since I'm CCCing now. Now that, let's just go this term. Okay, so you survey. $1,200 CCC students. Let's go stat students. And found that $302 were Caucasian. $398. Don't want to get, no, I want to get higher than that. How about 440 were Hispanic, and the rest were other races. What can be concluded? Any questions? Okay, so notice the survey question. What is the survey question here? What are you going to ask the student? So what's the survey question? Yeah, what race are you? And the person's not going to say yes. Okay, the person's not going to say 102, right? The person's going to say Hispanic or Caucasian or African American or Asian or whatever they might say. Okay, so note that this is another example of a qualitative survey question. Is that clear? Qualitative, not, yeah, it is not yes or no question either. And that's why we're in the chapter 11 ideas here. Okay, so this is also going to be a goodness of fit test. Because we want to find out is, has the distribution changed or has it not changed? So there's another goodness of fit test, because that's what goodness of fit tests do, is they want to say, is the distribution the same as what you expected, or is it now different than from what you expected? This is not about uniform. We're not trying to show the distribution's uniform. We're trying to say, is the distribution different than it was last year? Any questions on that? So in this case, H naught is the distribution. By the way, that word distribution must be in H naught and H1. Distribution, and if you want the racial distribution, this term for CCC stat students is the same as what it was last year. Any questions at all on H0? Okay, the good news about this, if using a computer, which you will be for the test, is for H1, we only have to make minor changes. What's the only change we have to do? So what's the only change we need to do for H1? Yeah, we need to put the not in between the and same. Sorry, between is and the. So the racial distribution this term for CCC students is not the same as what it was last year. Any questions at all on H0 and H1? Okay, so again, there's more writing, but the good news is that you can copy and paste into H1, and you can also copy and paste into your conclusion. So you got to write a whole sentence, but then you get to copy and paste it 3 times. So that's always a good thing. Okay, then the next thing we're going to do, just like we did before, is we're going to create a table. And we had 3 races. So I am going to do a observed and expected. Sometimes you do O and E, by the way. So I'll do it that way. Kind of shorter to write. And our races are Caucasian, Hispanic, and other. Any questions so far? Okay, the observed are very easy, 302, 440. How do we find the other? So what's the other? How do you find it? Yeah, 100 minus 35, not minus 35, minus 38. But yeah, that would be a percent, but we don't want percent, so we want totals. So you know that it's a subtraction, but it's not from 100, it's 1200 minus 302 minus 440. And notice that 302 plus 440 is 742. 1200 minus 742 is 458 if I didn't write in my head. Any questions on that? Yeah, it's given right here. Can you? Hopefully you can see it. You guys can. You should be able to see the desktop, right? Yeah. So it's there. Okay. Now we want the expected. Okay. So this is different. This is not about being uniform. This is about being the same as last year. Well, last year, 35% were Caucasian. So if we want the expected Caucasian, we take 35% of 1200. So let's do that. 0.35 times 1200. And you get 420. And for the Hispanic, now we don't want 35%, we want 38%. So all I have to do is change that 35 to 38. And you get 456. And then for the other, okay, now for the other, well, 35 and 38 is 73. And that leaves 27 left, right? So 0.27. and that gives us 324. Any questions at all on creating this table? Any questions? Okay, so now we go and do what we did before. We go to our calculator. Let me write this out so I can go find it. 302, maybe just write it out. 302, comma, 440, comma, 458, and 420, comma, 456, comma, 324. And the good news is I can copy and paste. Let's go to the calculator, pop them in, and then pop the other one in. And hit calculate. And what do you see? What do you notice? Yeah, 0 for the p-value, and the test statistic is about 89.13. So now I can go and I can say the test statistic is about 89.13, and the p-value is approximately equal to 0. It's not equal to 0 because it's actually, even though it says 0, that's in 4 decimal place of accuracy. So close enough to 0 that we know what to do at this point, no matter what your level of significance is now. So what's the answer? First few words. The conclusion. So what do we say? Any thoughts? There is, I'm going to say strong statistically significant evidence. To conclude that, and now I just redo H1. The racial distribution, this term for California community college students, is not the same as it was last year. Any questions at all on this example? Okay, I do want to know I made up all these numbers, so please don't quote me on the numbers. But these studies could be done. Okay, notice, by the way, here's what this does not tell us. It doesn't tell us which proportion is the culprit for being different. Okay, what it doesn't tell us that at all. Is that clear? Okay, if you want to kind of figure out, well, now that we know they're not the same, which one is the one that really made it different? Any guess on what you have to do? And from now on, I'm going to start saying this a lot. Any thoughts? All right. If I don't hear it from you, you're going to have to take another statistics class that's advanced. There's elementary stats. But there are other hypothesis tests that once you actually find out that the distribution is different, then there's a hypothesis, then there are hypothesis tests that will kind of do the granularity to decide, well, which ones are different and which ones are not different. but we're not doing that in this class because that's too advanced. Okay, all we're doing is saying, is there a difference? Any questions on this idea? Any questions? So what do you think? Does this look hard or does it look easy? Middle of the road? Sometimes I'll present the level of significance. Like on this one, I don't need to. P-value is 0 with 4 decimal places. Okay. On the other hand, on the last one, we really need to talk about level of significance because that one's in that middle ground area. Okay, but I wouldn't feel guilty at all on this final example, not giving a level of significance, because you should all know that if the p-value equates to 0 to 4 decimal places, then it's strong statistically significant evidence. Okay, if I hadn't on the first one, so for if I hadn't on the first one, then you say there's evidence, but you don't. There's statistically significant evidence, but don't use the word strong, because we're really close to that 0.05 mark. If it was say 0.06, then you would say there's weak statistically significant evidence. If you're not given a level of significance. Does that make sense? And if it was say 0.17, you just say there's insignificant evidence. So those are the different cases that could happen. Very good questions, though. Very good questions. Okay. What I want to mention, are there any questions? Again, we're kind of at the end. I don't have time to do a whole nother example. I kind of skipped the normal distribution, but it's not that much different. Are there any questions for the project, especially? Because that's the big thing that's coming up. Are there any questions at all? Because this is the time. And I'll also have office hours after this too. I'm looking at the clock and it's about time. We have a few more minutes left. And I didn't take a break, so it's about right. I might stop share and stop the recording.